Hello, here's our next video covering examples from section 4.3 of our calculus text. And we're just going to look at one example in this video, and we're looking at it right here. So let's just read it real quickly. This is the graph of the derivative f prime of a function f of x. So this is the graph of the derivative. We want to keep that in mind. That's really important. And we want to answer the following questions about f. And we want to give reasons. So one thing to really notice about this question is that we're being asked about something that we're not looking at. We're looking at the derivative, and we're being asked to say something about the function f of x. And so we're again, I'll say this, try to be real clear about this. We're being asked to answer questions about something that we're not looking at. But we can use the information that we've seen earlier in this section to help us answer these questions. So let's look at the first one. On what intervals is the function f of x increasing? So let's see if we can try to answer this question and give reasons. So I'm going to talk through it first, and then I'm going to write a little bit more succinctly. So from the previous video, from your reading of the text, we know that when the derivative is positive, the function is increasing. When the derivative is positive, the function is increasing. So what this question is really asking us to do is to look at this graph and answer, when is this graph taking on positive values? So what we can see is that f prime of x is positive on what intervals? Well, it's positive here until we get to -5. So it's positive from -infinity to -5, and then it's positive again between -1 and 4, and then it's positive again from 6 onward. And so f is increasing on these same intervals. Because f is increasing when f prime is positive. Our second question is asking us about decreasing behavior instead of increasing behavior. So we make the other connection that we saw earlier, that a function is decreasing when its derivative is negative. And so we would say that f is decreasing on the intervals where f prime is negative. So I'm going to be a little bit more direct in my answers this time. So f is decreasing on -5 to -1, from here to here, and from 4 to 6, here to here, because f is decreasing when f prime is negative. And that's exactly where we see the graph of f prime being negative. It's below the x-axis between -5 and -1, and then just briefly between 4 and 6. Our third question is asking, what are the critical numbers of this function? Again, the function that we're not seeing. So we want to remember the critical numbers are places where the derivative is 0 or undefined. So we were looking for f prime of x equal to 0 or f prime of x undefined. Now this function is not undefined anywhere, so this is not a consideration in this example. And so we're looking where the derivative is 0. Well, let me erase what I've drawn so far so we can look at this. And so f prime is 0. Well, we're looking right here, right here, right here, and right here. And so f prime of x is 0 when x is -5, -1, 4, and 6. So these are the critical points of f. Our fourth question is, at what values of x does f have a local maximum? Now we're not asking about where the graph that we're looking at has a local maximum. We're asking where the function that we're not seeing has a local maximum. And so that's going to be, so we want to remember that a local maximum from the first derivative test occurs when the derivative goes from positive to negative. And so we can think about where's the derivative going from positive to negative. Change the color here, something a little brighter. So f prime goes from positive to negative here, and f prime goes from positive to negative here. So let's answer that then. So f has a local maximum at x equals -5 and x equals 4, because those are the points, those are the x coordinates where f prime changes from positive to negative. And similarly, if we're asking where does f of x have a local minimum, I'll use a different color here. F prime is going from negative to positive here, and f prime is going from negative to positive here, and that's exactly where the first derivative test tells us that we have a local minimum, when the derivative switches from negative to positive. And so I can answer number 5 then. F has a local min at x equals -1 and x equals 6, because those are the x coordinates when f prime changes from negative to positive. Our next 2 videos will look at some examples where we are given functions and we find the intervals on which the function is increasing and decreasing, and where we have local max and local min values.